Hello, ladies and gentlemen. It's Mr. MoNaCo here.
And Mr. Milks.
In a first, we actually trying to combine our videos for this unit so that we have to post less stuff on the webs. We are in our second unit called
Atomic Theory.
And we're going to be talking about atoms and what makes them up in this particular unit. And the first lecture notes is on page 2-3.
This is where we're going to learn about the model of the atom and how it's changed over time and who are the scientists that are credited with all of these discoveries.
Yeah, for sure. So the first one, want to try the name, Mr. Milks? No, he can't say it right. This guy is named Democritus. He was the first person to think of the atom literally. He thought it up. He reasoned, so he had no experimental evidence here, that there must be a smallest unit of matter that is indivisible. What's indivisible means, Mr. Milks?
It means I can't split it up.
Yeah, you can't cut it in half. It's like already as small as it
He wasn't even a scientist. He was a philosopher.
Yeah.
And I think, if I remember correctly, right, he was thinking about an apple.
Grapes or apples or food.
He said if I cut it, I'd have half, and eventually I'd have to get to a point where I couldn't cut it anymore.
And that is
really
when he
got
like, well, wow, it's a big idea. And it turns out it really was. And this guy was like 500 BC. The next guy, John Dalton, literally 2,000 years later, English chemist in the 1780s or something, 1760s to 1844 or so, he came up with a theory of atoms that had 5 main points, 4 of which are right here.
Right, so first, atoms of any given element must be identical in size and mass. So if we're dealing with a carbon atom, the next carbon atom's got to be exactly the same.
Otherwise, it's not carbon, it's something else, and the theory gets thrown out.
Right.
The second point was that atoms can't be subdivided, created or destroyed. What's a subdivided?
I can't break it up into smaller pieces, going right after Mr. D up here.
Democritus.
Yeah, him.
Yeah. So the same ideas showed up in this next theory, but he added created or destroyed. He said, okay, if this atom exists now, I can't ever make it not exist. It's not my human power to be able to do so. Turns out that's actually kind of true.
Right.
Next point.
Then atoms of different elements combined in simple whole number ratios to form compounds. We'll think of water, right? H2O. 2 hydrogens for every oxygen, very simple ratio. I don't do 2.5 hydrogens.
It's a 2 to 1.
Can't
2 hydrogen, 1
that
oxygen.
thing.
No, you can't simplify. So atoms combine in very specific ways is another way to think about it, right? And the last point, atoms are simply combined, separated, or rearranged in reactions. They're not like created or destroyed or broken in half or glommed on together to make bigger ones. They're just rearranged a bit.
Right, that's kind of how he explains that a chemical reaction could even happen.
Right.
If first you say I can't create it or destroy it, well then look, I just did this, so what happened there?
Well, I must have separated or rearranged it.
There you go.
Simple enough. The next guy, J.J. Thompson, he was the first person to take those prior theories and discover something inside of the atom. It was called the electron. That's what he called it. And we call those a subatomic particle.
What does sub mean, Mr. MoNaCo?
Underneath, like a submarine would be like under the ocean.
There you go.
Subatomic, so something below or smaller than the atom itself. He coined this first one, the electron. He used this famous experiment called the cathode ray tube, where there's an animation we'll show you in class. He proved what the charge on an electron is negative, or he at least gave it the negative sign. And the first real, solid model of the atom that scientists could hop onto was made by him. It was called Plum pudding model.
Yep. Or we like to sometimes call it the chocolate chip model.
Chocolate chip cookies.
Let's see a picture of it.
We got a picture?
Yeah,
there we go.
So it does look a little bit like a chocolate chip cookie.
Yeah, so
Does anybody nowadays even know what plum pudding is?
Oh, only British people know anyways.
There you go.
Yeah, or whatever. So electrons are embedded in the spherical cloud of positive charge. That's how he kind of theorized that the atom must be after doing his little experiment. But let's move on, because that is not entirely true. New guy.
Rutherford came through and really disproved this particular model with his own Rutherford model.
Now, he might be called Ernst or Ernest. Not sure which, really. He was definitely in the British Isles there. He performed this famous gold foil experiment.
Yep. This is the one we all really got to know pretty well.
And we're going to show lots of animations on it just to make sure you can really get this. It proved that the nucleus of an atom is small, dense, and positively charged. He proved that the nucleus of the atom exists.
True.
Okay. You have something to write there, Mr. Milks?
I'm going to show you. Let's get a picture up so we can talk about this experiment, this gold foil experiment.
Okay, let's see what we got here. picture.
There we go. So we have a particle emitter over here.
Right. It's like a gun. It shoots alpha particles.
Right, right. And then here's this really thin piece of gold foil.
Like 1 or 2 atoms thick almost.
Right,
really thin.
And these alpha particles are so small that they can go straight through that bad boy.
Yeah, and that's what Rutherford expected. He expected to see them all go straight through, just like bullets through a piece of tissue paper.
And so the key now, and what really spurred him into this whole model, was this arrow right there.
Sometimes, every 1 in a billion or trillion bullets, alpha particles he shot, it bounced straight back at him. And he said, wait a minute, this is not right. Let's do the experiment again. Statistically, it became truth. It is true. These things bounce back very rarely, but they do.
Right. So it's hitting something dense enough to reflect it.
And send it back the other way.
Right. And then there's one other key. I'm going to change colors quick. These guys shooting off.
And weird angles.
At a weird angle. And that's because what we know is that positives and positives repel. And the charge on this alpha particle is positive.
He knew that.
Right. So if he gets close enough to another positive, it should repel me or
push it away or bounce it off.
He can theorize that this nucleus was positive.
Right. So really important. Built off all the discoveries of the previous scientists. Nowadays, we've got a couple more models. Notes on Niels Bohr. This guy was in the 1900s finally. And he created this Bohr model. It's the best known model.
Yep, you can see it by his picture. Look how much,
younger.
He looks.
And he was actually young when he figured it out, in his 20s or so. He studied electron behavior during excitation and emission, which are fancy words for absorbing energy and releasing energy.
Right, yeah, give me lots of energy, I get excited, and then
I'm going to lose it all, and I admit it, and I'm going to let it go.
Yeah, I think of a 3-year-old. Yeah, they get all excited running around, and then they fall over.
He discovered electrons move around the nucleus in orbitals, kind of like planets move around the sun. So sometimes we call this a planetary model of the atom, but it's really a Bohr model of the atom. Okay.
And then the electrons are in these outer orbitals, and the farther away they are from the nucleus, the more energy they're going to have.
Right, so that's kind of really how all there was to it.
Right, and then this whole excitation emission came, this theory that each orbital that I move, it's a specific amount of energy.
Like steps on the stairs.
Exactly, like steps on the stairs. And that energy comes back to us in a form of light.
Right.
So now I have it at a specific wavelength.
Right, so if you like jump 1 step, you get like blue. If you jump 3 steps, you might get like green. 4 steps, you might get like ultraviolet or infrared.
Right.
And the cool thing about his theory and the proof of it was that you could start to look at light, glowing lights, with a special tool and see what wavelengths of light were coming off of it.
Now you know what elements are there.
And then they just started figuring out what elements were there.
A little side note, right?
Yeah.
But one of the coolest things I think this is if you do that on those high-powered telescopes,
right, you can tell.
You can tell what the life cycle is of a star based on what element is fusing inside that star. And that's some really cool science.
And nowadays, how do you think they're figuring out that there's liquid water on Mars, Mr.
I heard that last week.
It's true, they say.
They say.
NASA says, but they're doing the same exact thing. They're looking at Mars with a telescope and looking for the electron fingerprint of water based on Niels Bohr and all his research work, which is really cool.
Yeah.
Really cool stuff.
Let's get to this wave mechanical.
Yeah, let's get done with this. Let's move along.
Yeah.
We're doing good.
Yeah, sorry it's so long, but this is fun.
This one's the simplest one because you have to know the least about it.
Seriously. Well, because see how it says mathematically based?
Calculus based.
Yeah, this is the stuff that makes Mr. MoNaCo lose his hair.
This is the kind of math that doesn't have numbers in it.
Yeah.
It's the kind of math that's strictly letters and ratios.
It's my math.
It's Milk's math. I can't stand it.
But that's okay. But it just said that now, all we really need to know is that instead of this, it redefined this orbital as specifically the most likely place I'm going to find an electron because they move. And
they aren't moving right around like a planet moves around the sun. They're moving in a much more complex path that does have a specific amount of energy like the steps, but it's not the circle that Bohr said it was. That's the big idea here. And an orbital is where you're going to most likely find an electron, right?
They have these cool shapes. That's what's in this picture. But we're not even going to get into too deep. But I just want to know that it happens.
It's called a wave function. It also means that electrons behave like particles and waves. Carrying on. Let's wrap it up.
Yeah, here we go. So, a few key points about each scientist. You got to come up with a way to remember them. Who did which experiment, guys? The gold foil experiment. Who was it?
Got to know the gold foil experiment.
What was so important about that gold foil experiment?
Yep.
Got to know it. How are you going to remember it?
So if this isn't enough for you, go ahead and search on the internet. Literally, gold foil experiment.
You're going to find some cool
So
interactives
much.
that talk it through.
A lot of
But it's
YouTube
gonna have,
stuff, too.
It's going to have this really boring voice on it.
Yeah, it's
you know.
because, he's just trying to talk
He's
to
a
the
scientist.
masses. And some scientists don't know how to talk to people.
Cool. See you guys tomorrow in school.
Thanks for watching.